Okay, so what we're going to look at today is more about perpendicular lines. How do we know if they make perpendicular lines? What kind of angles? 90-degree angles. Okay, so perpendicular lines. Okay, so these make right angles. And how do we know there's a right angle? We have to put the little box or the little square in the corner. Okay. So we know if two angles have the same measure, meaning the same angle measure, they have to be this word congruent. Okay, so congruent means they have to have the same measure. So would you agree all right angles are congruent? Yeah, so if we have any two right angles.
I would argue. Because what if they're intersecting?
That has nothing to do with having a right angle. Okay, so congruent means the same measure. Do they both have the same measure? Yes. So we say angle A.
Like if I have like 126, 126, they're congruent.
Right? So if it's a right angle and a right angle, we could say angle A congruent to angle B. Okay. Notes. Okay, if two lines are perpendicular, they intersect to form how many right angles?
Four, guys, obviously.
How many? One? Okay, let's think about this. Vertical angles are congruent. So if there's a 90-degree angle at one, yeah, and then these two, what do we call these kind of angles?
Same old.
Not
90, 81, 180.
Okay, 180. Why do these two add up to 180?
90 plus 90 plus 90 plus 90.
Okay, and they make a linear pair. So these two. So if there's one right angle, then all four have to be right angles.
No. Because what if they're different measurements?
What?
Bruh, listen. Guys, what if...
David, there is no what if.
Well, hey, wait.
One right angle
What if I put the line down?
means all four are right angles. Okay.
You got me there.
Okay, now remember we talked about the symbol for perpendicular was this upside down T. Okay, so R is perpendicular to S and R is perpendicular to T. So we want to determine whether there is enough information to say whether the statement is true. Okay. Okay, well, let's start with, all we need to do is say, is there enough information? So can we say 3 and 5 are congruent? Looking at the picture. Yes, that's true.
Because they're both equal to 90.
Because they're both equal to 90.
Oh, but like if it was like 3 and 2, it doesn't. No.
Okay. Well, in the homework, I might have an explanation. So again, why do we know? Well, they both have the little square. That means they're both 90 degrees. So they have to be congruent to each other.
But like, so for like 5 and 4 and 2 and 3, since they don't have right angle,
okay. Let's not. You're very close there, especially for C. But take a look at, what do we know about 3 and 4? These are what kind of angles? Starts with a V. Vertical. What do we know about vertical angles? They equal the same. So this is 90. That's 90. So just look at 4 and 5. Do 4 and 5 have to be congruent then? Yes. Because vertical angles.
Wait, how do we not know that they're all 189 or 89?
Can you explain B again? I'm confused.
So vertical angles are congruent. So if this is 90 degrees, angle 4.
Yeah, I know.
Remember, anything that makes an X, like when they intersect,
they're all equal.
These two have to be the same measure. So if you know one, then the other side has to be the same.
Usually it would be like 1 and 3, right?
How is 4 and 5 vertical?
No. 3 and 4 are vertical. And then
Wait,
since...
but that's not what I was asking. I was asking about
Yeah, yeah. So 3 and 4 are vertical, and then these two are congruent.
What do you rate the last 9?
They're both 90 degrees.
Last 9.
Okay, now, the last one, angle 2 congruent to angle 3. Do we know anything about angle 1 and 2? We have no little
We know
box.
that 3 is 90, so 2 should be also 90.
Ah, it's 90. It's 90.
Is that not true?
No, so
Wait,
we
so
do
what
not.
is 90 at all? There's no.
No. So look at where angles 1 and 2 are. Look where these lines are crossing. Do you have any squares in that corner?
Yeah.
In 1 and 2?
I've never had a square for a 90 degree.
Look, if this is 90, all 4 of these are 90. But there's no box here.
Is it not just U and R? Those lines, U R. You see that?
Yeah, but we don't.
We don't have information.
There's no information here.
Trust me.
Okay, so there's no
I'm confident on this one.
little square here. So just because it looks 90 doesn't mean it is. It could be 90.3 degrees. Okay, so let's take a look at the next page. So again, look at where the little boxes are. Here and here. Now, if this one is a little 90 degrees, what do we know about all 4 of these around here? 90. So this is 90, this is 90, this is 90, this is 90. There's also a little square at angle 10. So what does that mean at all 4 of those? Remember what I had just said. If there's 190 degree, all 4 of these have to be 90. Now take a look at where 8 and 9 are. Is there any little square? No. So there's no information there. So now let's look at what can we determine. So it says determine again whether there's enough information to conclude the statement is true, and then explain. So we'll either say we'll just abbreviate. Okay. All right. So let's take a look. So after I've labeled everything, take a look. Are 6 and 10 congruent? Yes. Both 90 degrees. Yeah, that's all you have to write. I'll just write both 90 degrees. Okay. Over here, 7 and 10. Same, right? Yes? Now, 7, because it was a vertical angle, I'll just say, again, they're both 90 degrees. Well, I'm going in order. 1, A, B. Now I'll do C. Sorry, I go over. 6 and what was the other one? 8. No. If it's no, I'll just put no. Okay, 7 congruent to 11. Yes, they're both 90 degrees again. Okay, 7 and 9. No, not enough information. Again, we had said there's no little square, so we don't know over in that area. And finally, 6 and 11. Yeah. So the only ones we don't have enough information would be 8 and 9. All those other angles are going to be congruent. Bless you. Good questions. Okay. If 2 lines intersect to form adjacent congruent angles. Okay, adjacent. If I say adjacent means they are next to each other. Do you remember that? Adjacent. Like if I say Aiden, you're sitting adjacent to Mark, you're sitting next to him. So here's angle 1 and 2. If these are next to each other and they're congruent, what do we think is going to be true about these lines? Okay, they're going to add up. So if I say angle 1 is congruent to angle 2, and what else do I know? Angle 1 plus angle 2 adds up to 180. So what does each angle measure have to equal? If they're the same, they both have to be 90 degrees. So if they make 90 degrees, the lines are perpendicular. Perpendicular. Okay? So does that make sense? What's that? Oh, this is kind of backwards from what we were looking at on the previous page. So this just says if these two angles make a linear pair, like if they're next to each other and they are congruent, then the lines have to be perpendicular. Okay, two sides of an adjacent acute angles are perpendicular. Then the angles are, okay, again, what does the square mean? 90. Do you remember what word we used to describe angles that add up to 90? Complementary. Okay, so just like in the last chapter, you had some vocabulary. You still need to remember those terms because as we know in math, everything builds.
Wait,
So
congruent angles are supplementary and
well, congruent angles are just the same measure.
oh, okay.
Okay, so that's why these were both 90 and 90. Okay, complementary just means angle 3 and angle 4 have to add up to 90 degrees. According to this picture, does anything say that 3 and 4 are congruent? No. But if I gave you angle 3 is 30 degrees, could you figure out angle 4? Yes, right? Complementary is something that we did in the last two chapters. Yeah, they just have to add up. Okay, so now our examples. So, okay, we see the little upside down T, and we can also see the right angle. GEH is 30 degrees. Oh, that's convenient. So what do we know these two have to add up to? So I'm going to have 6y plus 30 equals 90. Again, we've this is a topic we've already visited, just in a different format with perpendicular lines. Okay, I want to isolate y, so I'm going to subtract 30 from both sides. Oh, you got it, Aiden? Good. So I get 6y equals 60. Divide both sides by 6. Good. Y equals 10. Okay. Questions? Okay. Good. All right, let's look at example 4. What do you think? Okay, so EFG and HFG are congruent. So what does that make each of these? Each of these angles have to be 90 degrees, okay? We had seen that in that, do we agree these are adjacent angles? Are they next to each other?
Yeah. So the answer's just 9.
Well, we want to find the value of the variable. So what does 5x have to equal? 90. So we're going to divide both sides by 5. Okay, 5 into 90. Let's see. 5 goes into 90. Good. So 5 goes 18. Good. All right. How about B?
6 there, so 9y.
So what do these have to add up to? 90. These are what we call complementary angles. So do you see a pattern here? They're either going to equal 90 or they're going to add up to 90.
Oh, that's pretty cool.
Okay?
It's supplementary, huh?
Okay, not supplementary, complementary.
Same thing, huh?
Not the same thing. Supplementary add up to... Yeah, well, let's see. What's 90 minus 36?
Yeah, it's
What do we get when we subtract here, though? 54? Divide both sides by 9. Good. Y equals... Okay? Yes.
You want to take a nap during the meeting?
No naps. We're almost done. This is the last one. Okay, I want to find the values of x and y. It doesn't matter which one we do first. Let's say we want to solve for x. So I'm going to ignore everything except for the 6x and the 3x.
Oh, 6x plus 3x equals 90.
So if this is a right angle, this is also a right angle. So 6x plus 3x equals 90.
Well, I feel like it's so 8x. X is 10, right?
Yeah, what's 9 into
6 plus 3 is
10?
Oh.
Okay.
And for 12y
Okay.
minus 10 is equals 180.
Well, how much does this angle have to be?
90.
So we're not going to make it equal to 180. We want to make it equal to 90. So here, 12y minus 10 has to equal 90.
1 plus 10.
So we're going to add 10.
12y equals 100.
Okay, now it doesn't go evenly. So it's a good thing we were practicing those fractions. We want to put, yeah, what can we divide the top and the bottom both by?
8.3.
So we're going to write it as a fraction now. I could divide the top and the bottom both by 4. Okay, 100 divided by 4 is 25.
I see two.
If you put it in your
Oh,
calculator, you're going to get like a repeating decimal. I actually prefer to just leave it like 25 over 3. If you're using the TI Inspired, it will automatically.
No, if you do control.
I know, but if you just put it in, it like automatically will write it that way. Okay, good. All right.